Hello everyone, welcome to a new tutorial on UMEP, the Urban Multiscale Environmental Predictor. Today we will cover one very exciting and very interesting video explaining how we can conduct an climate sensitive scenario modeling using the UMEP tool and also the SOLWEIG model. So in UMEP there is one processor for outdoor thermal comfort. So the SOLWEIG model calculates mean radiant temperature. So today I'm gonna teach you how you can generate different scenarios for a specific study area or site and test different, let's say, options, climate sensitive options. So if I want to first explain briefly, I will introduce what I mean by a scenario modeling. So a scenario modeling, I will conduct that in Solveig, and which models or simulates mean radiant temperature. Okay, that relates to outdoor thermal comfort. Okay, so we're gonna cover three aspects today. One, it is tree planting. In tree planting, what we're gonna use is the tree generator tool, which is part of the UMEP preprocessor tools. The second one will be testing different buildings, footprints and heights, different locations of buildings. So for example, if we want to calculate what will be the effect of, for example, several narrow buildings or one tall building or a skyscraper, whatever we want to do. And to do that, we're going to use the DSM Generator, which is available also in UMEP. And as part of this, we will also test another very interesting, let's say, heat mitigation strategy, which is a shading device. And we will also use the DSM generator available in UMEP. And the third and final topic we will cover is how we can test or add or model the effect of green roofs and green walls. Um, this is a very, let's say, a more challenging aspect of a scenario modeling with Solvig, because Solvig has some somehow limitations on testing green roofs and green walls. So I found somehow a method to generate these green roofs and green walls using the existing tools in UMEP. One of those is the green roof. It's just using the land cover classification. It's just by assigning um, let's say a grass value to a roof building of a roof or of a building, and the green wall is using the tree generator as we did it before as well in UMEP. So we have here three key, let's say, strategies, climate sensitive strategies, and each of these strategies will define a completely different scenario, and you may be able to test different assumptions. If what happens if we align all the trees in a row, what happens if we create a courtyard that is shaded, and what happens if we combine shading with trees and green roofs and green walls. And that's what we will try to do today, which is basically what you can do with other similar CFD simulations, like for example MVMet, right? But obviously Solvay has some limitations. There are a lot of papers on what are the pros and cons, drawbacks, and somehow caveats that you need to consider about the Solvay model. Um, there is one aspect that is difficult to model, and is the fourth that we are not going to do, which is cool pavements and cool roofs, basically cool surfaces. Why? Because the model assumes that the higher emissivity or reflectivity and albedo will end up adding more short wave and long wave radiation inside the canyon, and that consequently will increase temperatures, either Kelvin or Celsius, or inside the canyon. So that will be in detriment of the autothermal comfort, and obviously we will have a higher mean radiant temperature. So this is something that is how is the model deals with this information. So there are somehow some limitations on modeling cool surfaces in this model. Eventually, we'll maybe let's say sort it out, but not at this stage. Okay, so we will focus on this. If you have checked my previous video tutorials, I have 3 or 4, I have 5 video tutorials on UMEP. But in the last couple of them, I already focused on how to generate your own spatial data, your own methodological data. So these were take on what already built before to develop this video tutorial. So have a look at those videos first if you feel a bit lost of what we're going to do. But basically, for the SOLWEIG model, what we need is a DEM, a canopy DSM, and obviously a DSM. Okay, so what we'll generate, we're going to start now generating the data that we need for our first scenario. So the DEM, the digital elevation model, in this case, we are not changing the ground surfaces. So we don't need to modify that, and this will be the same DEM in all the scenarios, okay? But what we're going to change is our canopy and our buildings first. So back to our first, let's say, set of methods, we're gonna test tree planting. So the first thing for tree planting is just to have an initial canopy DSM. We have this canopy DSM that we have derived from LiDAR. I already explained this in previous video tutorial. So the next step is what happens if we want to plant new trees. Let me have here the buildings just to give a little bit of the context. So what happens if we add some trees, a line of trees in this, let's say, avenue? So we're going to use the tree generator. The tree generator is another um, spatial data preprocessor available in UMEP. It requires 4 attributes. One is the tree type, in which the number 1 corresponds to conifer, a conifer or evergreen tree, and number 2 to a deciduous tree. You can also remove the vegetation somehow by adding a type 0, so it will be a null value and will not be estimated. Then you need total height, which is the other value in meters above the ground level. You need to have the trunk height. By trunk height, I assume you understand, well, this is the ground, this is the trunk, and this is the height of the canopy. Here you can assign a value, for example, 4 meters above the ground level, and then the whole tree will be 8 meters, so you will have 4 on the top of the canopy. But we have trees like, for example, in which we have a cypress, in which we have maybe 1 meter from the ground, and the tall will be the whole height will be 12 meters. So this is related somehow to the previous concept that we found, that is the percentage of the canopy of the trunk height as part of the model. But if you have this information, and you need to input the information here. Diameter, it refers to the circular diameter of the tree in meters. Okay, so how we do that? Very simple. We need to create a new layer, and this new layer we will call it create layer new shapefile, and we will call it, we need to find the location, trees, and we will name that scenario 2. Okay, S02. So the trees of scenario 2, it's what we are going to add on top of the existing trees. Okay, so if you don't want these trees to be there, or we are going to remove trees, what you have to do is go to your LiDAR, original LiDAR datasets, remove the trees if you want to remove trees from the LiDAR, and then follow the steps that I explained already in my previous emails on how to generate your own spatial data. Make sense? So simply you get rid of the point clouds corresponding to these trees, for example. And then so they will not be in this canopy DSM. Okay, but what we're going to teach you right now is how to add trees, not how to remove. But if you want to remove, you have to remove them in the LiDAR dataset. Okay, so we're going to add these trees. They have the location, leave the other things as they are, and then we will create a geometry type point. We are not gonna include Z and M values. We're gonna choose the appropriate coordinate system, which is in this case corresponds to the zone 55 GDA 94. Could be the GDA 2020. This is for the geodesic datum of Australia. Okay, so that is our CRS, which is the coordinate reference system. We will create the different fields that we need. So one of the first fields that we need, we don't need the ID, but what we need is, based on this information, is the tree type. So there is a specific way of calling them T-type. Look, so we will use the same, let's say, coding T-type is the building type, and it will be a whole number because it is either 1 or 2. So we add this field to the list, the T type. Another another of the parameters we need is the total height. So we call it this total height. So we add here tot height, and the whole number. This is a decimal number. We just don't need a lot of precision. Just we can put 2. We add to the list. Another value that we need is the trunk zone height, which is we would call it trunk. And again, it's a decimal number with 2 precision. And finally, the diameter, which is decimal to precision. We add this. We click, we can choose the ID. We don't need IDs, so we can remove that, and we just keep the type, height, trunk, and diameter, and we create OK. So these trees are right now, the layer is here. Obviously, we don't have any point. So we will start adding a couple of points by editing the trees shapefile, turning on the toggle editing. And here we add a create add point, and then we just click in a specific location, and let's imagine, or before that, let's imagine we want to know what the average diameter here will be a 12 meters tree, for example. Or if we want to, we have the specific size of the tree, you add it there. Okay, so let's add the point. Let's put this point. Let's imagine the type. If I want to be a conifer, the total height will be 15 meters. The height of the trunk tree and the diameter will be 5 or 10 meters. Okay, that's our first point. What we could do, if we have several of these same points, we can select that point and create multiple copies, or we just simply can input a new type, which is number 1. The height will be the same. The trunk can be different. The diameter could be, let's say, 8 meters. Then we have another tree in which the diameter will be, let's say, 20 meters. No, let's say 15, not to complicate this too much. For here, 15, let's say 20 meters high, and the type will be also conifer. Now we put here perhaps a deciduous tree, which is number 2, deciduous, and the height will be maybe 25 meters, the trunk will be 5, and the diameter will be 20. And we can repeat the same here. We can copy this, let's say, Control C, Control V, and they were paste, and we just have to move that one here, and that's it, because it's based on top of each other. So we save this. For now, we have this line of trees. We don't need to add too many right now. Okay, it's just for demonstration purposes. We finished toggling and editing. So now the next step is deselect everything. okay? And we have our lines of trees here, and we want to see the difference perhaps in the cooling of this area, okay? The effect of adding trees and lines or not, adding a wide tree canopy. To make it very interesting, let me measure these trees and let's assume, oh, these are 18, nearly 20. So let's toggle again. Let's copy this one here and then let's move it. So I want here one, and then second one here. So you will see what happened when they overlap existing trees. And then let me select these two to save time, and then let's move and put them here, and now again move them here. So we are creating a consistent line of white trees, deciduous trees, okay? These are evergreen or conifers, and these are deciduous. We save everything, and then it looks interesting, correct? That's much better. So we added here a line of trees. Now, so what is our next step? Our next step is going to the UMEP preprocessor spatial data tree generator. So we choose our vector point. Here is the t-type, the total height, the trunk, and the diameter. We can use Boolean building grids to mask information to avoid these trees to, let's say, overlap each other. Okay, I can show you that later. For now, there is no building here overlapping, but if we add a building, I will show you. So we're gonna generate this second scenario, okay? But we're gonna generate different scenarios. You will understand what to do. So we need here our raster DSM, something that we don't have yet. So we go back to our DSM. How we generate the DSM? Remember, we go to UMEP, preprocessor, DSM generator. We have our DEM already there. We have our buildings. These buildings were digitized manually, or you can derive it from LiDAR. We grab the building height. We create the DEM as an extent from the layer, the resolution of 1 meter, and then we save it. And we're going to call it DSM. DSM is scenario 1, okay? Because that's our basic one. Okay, and we run it. Oh, there is an error in the Python. Let's see what's happened. DM, maybe it's on the name buildings, scenario 1. Correct, building height. Okay, extend the, okay, DSM 01 underscore. I want the underscore. Save. And we run. No. So there is a problem with the geometry or occur executing Python code. So let's see what's going on here. Okay. So what happened is because it was already open, the preprocessor for the tree generator, you have to close that and now rerun the DSM. We have the DEM. Obviously, we need to go here, just correct. Where it is UMEP here. Oh, sorry. We have our preprocessor. DEM, buildings, height, building height, DEM, 1 meter, and we call it like this, 01, yes. And we run it, and then we have it successfully there. So now we have our DSM, correct? So as you can see here, it's already generated the DSM. Good. With this information, now we can go to the preprocessor, spatial data, and tree generator, and then use the trees, t-type, the total height, the trunk, the diameter, um, our DSM, which is here, raster DM, which is only ground, which is here, and then we choose merge with existing DSM. If we don't choose this, what it's going to do is just gonna to disregard the existing information, and we will not merge it. Okay, so we have a vegetation. Yes, we have the canopy DSM, which is what we want to merge. Then we select the folder. Here are our data sets. That's okay. Select the folder, and we need to add the name or select the folder, and then will be automatically generated there. So we run it. Okay, it has been run. So we go here to our folder, and then let's imagine, no, this is the existing one. I want to go to the existing folder to see what's going on. So it generated these new two tips that are underscore. These are the new canopy DSMs and also the trunk DSMs. Okay, because we already put the information of the trunk. We may not need this for a moment because the similarity is very similar. Anyway, we don't need this for now. We just need the canopy. You can see here the smaller trees, the bigger trees overlapping to each other. Similar situation here. So with this process, we can export, save as, and then we will name it properly like canopy DSM scenario 2. Okay, we save, correct. We remove the existing, and I want you to compare with the other one. So what I will do is I will use a pseudo color, remove the opacity here, and so you will see here the difference. Okay, the canopies have changed. Now they have been added, so we can bring this to the top so you can see where the location of the trees. The new canopy DSM is significantly different, obviously because of the new trees that were added there with new heights. So that is our canopy DSM original and a scenario 2. So we have learned now to generate that. So how that affects thermal comfort, I will show you in a moment when we run finally the SOLWEIG. Okay, so we have generated the first step, which is our tree planting. Now we will go to the number 2, which is testing buildings and shading devices. So with this new information, this is the existing DSM. And let's imagine here in the middle of this square, or in this case is a ground, is a bare soil. This is a new redevelopment. Okay, let's imagine the redevelopment is here happening, and then all these sort of yard for the trains, it's a train yard, will disappear, and they will revegetate some areas, and they will create a new building here. So what is the next step? The next step is we have here our DSM. We want to build a new building. So these are our existing buildings. If you open the attribute table, our buildings have height. We don't need all these statisticals. We can delete some fields like stats. We can delete some like this one and these stats. You're not to confuse. Okay, let me delete those things. This and this. Okay, so we have here our heights for our buildings. Okay, let's imagine it's going to be a new tower in the middle, right? So what we should do is these buildings are our scenario 1. So we don't want to change that. So we will export these features as buildings underscore scenario 2. And we will save that in our existing folder. And we will call it here. This is our folder. Scenario 1 is there. We will call it scenario 2. It will be polygon, and the rest just remain as it is. We click OK. So we have the building scenario 1 and 2. So in the scenario 2, what we want to have is one building here in the middle. We just need to start editing, and let's create the building. So we can turn on our canopy not to overlap existing trees, and let's say here is going to be the new building, which is a huge building, let's imagine. And let's, it's number 25, because I know the ID. So the height for this will be, let's imagine it's a tower, okay, or relatively high. Yeah, 60 meters, okay. Let's imagine it will be approximately 20 stories, okay. So we proceed and we save this information, okay. So there is saved the information, okay. So we have route the building there. We save this, and obviously we need to create a new canopy. Okay, so we have, sorry, a new DSM. So we have already our DSM for the first scenario, as you can see here. And what we need is, we already have it, sorry, it was here. And we need to add the building here. Say how I can do that. Very, very straightforward. With the same preprocessor tool, the DSM generator. But instead of choosing the original digital elevation model, we are gonna overimpose the new building to the first DSM or the DSM from the first scenario. That is the trick. That's the whole thing. Instead of choosing the DEM, you will choose the DSM from the first scenario, which is what you see here in the screen. Correct? This one. And for buildings, we're going to choose our second buildings, the height of the building, and the extent will be the DSM, the same one here. Our resolution has to be the same, and then we will call it this completely different. We will call it DSM underscore scenario 2. So our scenario 1 will be the initial point, and then we will overimpose the new buildings there. It could be more buildings, but I'm just adding one just for, you know, purposes of explaining what we're going to do. And then we run this. Again, we have a Python error, and then I found that this is happening very common. So what we have to do is just save the information here. For some reason, this Python is coming after I open or run different, you see different warnings when I open and close and edit this. I just save this, and we just proceed to close the whole and restart the QGIS. So I will restart the QGIS. So here I restarted the QGIS, and I will open the existing project. Here it is. Then we're going to redo the work that we were trying to do. So it's DSM generator. We use our DSM as a base, not the digital elevation model, not this one, but the DSM. The building will be the second scenario of our buildings, and we use the height. We go to the extent from the layer, the DSM. We choose the proper location for that data set, and we call it DSM scenario 2.tif, and we run it, and now it runs. So now it should be there, the building. Okay, so as you can see, the building has not been added to the new DSM. And I would like to highlight why is this error occurring, because it may happen to you. When you create the building and you run the UMEP preprocessor, somehow the model cannot remember that that new building has been added to the edited layer here. So what you have to do is, well, delete that DSM, um, delete it also from the your browser, from your folder, removing the new buildings and re-adding those buildings back there. So these are the buildings we just recently edited. We can change the color here just to make it more evident. Let's say orange. Okay. Oh no. Okay. So these are the new buildings, right? So building 2, building 1. So you, after editing, you have to remove it from the layers and re-add it from your browser. Then run again the preprocessor as we did it before. So this good, I'm showing some errors you may encounter when you have this issue. So is the DSM-01, the building 2, the height, the DSM-1, the same, and then we just save this DSM-2, save, and we run it. And now when we run it, the new building is there. Okay, so if you want to visualize it, you can visualize this DSM here. You know, the new building is there, and this is the original one without the building. Okay, so that occurs for some reason when you edit something and you create new buildings, new trees. You have to save all the editings, remove it from the layers, and re-add it from your browser. Okay. Um, what we can do, nothing. So we have the new DSM with the buildings. Okay. But something peculiar here that I want to highlight is in our, we created a building, but I want to create also a shading device. How you create a shading device? Well, the shading device in this case it's an element that will be maybe a couple of meters above the building or around an overhang. It will be it's a bit difficult um, for the software to estimate that underneath the, let's imagine this is the building. Let's go down. Let's imagine where it is yeah. Let's imagine this is your building. And let's imagine you want to create an overhang here, or just in front of the building, just simply put a floating surface, right? The shading, let's imagine it is a canopy like this, and it's floating in the middle of the air, for example, in a car park. It's very hard for the software to understand it, right? So, so what we should do, in fact, is assume that this is another building. Obviously, there is not going to be 100% precise because it will estimate walls, aspect, and wall height. But we are going to do is not to include it in the land cover. Make sense? So that it will our next step. That's what we're going to do. We're gonna build another building or another canopy shading device, assuming it has walls like a cube, but will not be added to the land cover as a building. It will be respect the existing land cover underneath. Okay. This is a way to trick the system or the model, not the most precise, but I tested before and it worked. So how that it is translated here, let's delete our DSM as it is. Let's remove this. Let's keep it with the new building. We'll build here a canopy. So again, we edit this. We will, let's imagine, create here an overhang. Okay. We'll need to create here an overhang for this building. Let's make it on this point, close to the building. Let's imagine like this. Okay, up to here, and it will be a shading device there. Okay, this is our building 26 and our building height. Let's imagine this will be 5 meters above the ground. Okay, like a typical let's say canopy shading device. Okay, shading device. Look, we will save this. And what I showed you before, this will be our shading device. So we just save it, we stop the editings, and we remove it from our layers. And when we add it again from our browser, and now we need to delete this DSM. Again, sorry for that. And we rerun the DSM generator using the existing DSM, building, height, layer, DSM, resolution, and this will be the DSM with the canopy. Okay, so now we have the building and the shading device here. How it looks in 3D, it will look like simply like a building, okay? It would look like a building, but in fact, this is a shading device. What we're going to do later is to exclude it from the land cover, okay? So what we have done so far from our list, we have done our tree planting, okay? We have done our DSM. So here is the difference between, these are the trees and the buildings. So DSMs are different, good. Sorry, our DSMs are different. What else? Our canopies are different because we added new trees. So what is the next step? The next step, in fact, is to generate our green roofs and green walls. So let's start with the green walls. The green walls are very difficult as well to be generated. Um, I found another way to trick the system, if you want to call it. Let me imagine this is gonna be our building, and one of these facades will be a completely green wall. Again, for the system, it's very difficult for the model to estimate. Let's imagine the green wall will run from the second floor. Let's change this drawing to green, and let's imagine the green wall will be just covering this part of the wall. So part of the wall is not covered, part of the wall. This SOLWEIG model doesn't operate in this way. So I found a way to trick it is to assume that we have a lot of trees, vertical trees, one next to each other, very close to each other, and very close to the wall, and they will behave as they were not trees, but a green wall. Okay, so again, what you should do is turn on your trees, and then let's plant or let's edit to these trees, new trees, close to this wall. Okay, and not too close, because otherwise you will have some issues here when generating the canopy, because it considers the location of the buildings. They will be override, and then it will be a building in fact rather than a green wall. So let's keep some distance from the wall, and then let's put our tree type will be an evergreen. Our height will be 50 meters. Let's imagine we'll cover most of the height of the building. Our trunk will be 0, will be from the bottom, or if you want from 2 meters, the canopy will start, but anyway, it's 0 or 1 meter. And our diameter will be 0.5, it will be very small, because or 1 meter, our diameter, the size of the pixel. Makes sense? We cannot be smaller than the pixel, but at least the size of the pixel. If you're using a pixel of 1 meter, you cannot go below. Uh, Obviously, we cannot have a very wide, otherwise wide tree. Otherwise, it will perform like a tree, not like a green wall. So we have there the point, and what we're going to do is to copy multiple of these ones. Sorry, my mistake. And separate it, let's say 1 meter. Maybe like that. And what we'll do now is just to speed up this process. Let me copy more of this and move them. Okay, now this 6, and I will move them. Here's the move. We'll do the half of the wall to see how it behaves like that. So having done that, we save and we stop editing. And what I said before, after editing, what you have to do is remove the trees or any layer and then move it and bring it back from your browser. So there you have your trees. Obviously, we're going to modify this canopy DSM because there are going to be new trees here, uh, performing like a green wall. Okay, so the next step is we're going to remove this canopy DSM. We're going to delete it from here and we're going to create a new canopy DSM including this green wall. So we go to the tree generator, trees. Okay, we have our type, total height, trunk, and diameter. Um, we have here our raster with our DSM. Now we have to use the DSM including the new building, okay, because this is for our second scenario. So that's why it's really important you build all of these simultaneously. You need to know if you are going to use a DSM including new buildings, you have to include this new building because it will mask some parts overlapping of the building if they overlap to the green wall or the vegetation. So it has to be this new DSM. That's the correct. The initial tree generator we run, it didn't include this building, so it was not there, but now includes the new building. It's a new DSM. The DN remains the same. So be careful with these things. These little details makes a difference. We are going to merge with an existing canopy DSM, which is already there. And we don't have a trunk. We select the folder and we go to data set and we run. In this data set, there were already two TIFFs. We are going to delete this, not to create confusion or overriding information. Okay, and now we are ready to run it. Hopefully it will run and everything is fine. So we run it. Yeah, so this is our new canopy. Let me turn off. You will see here all these dots behave like a little points. Now let's keep it like that, but you can test different settings for your green wall. In this case, the green wall is 1 meter. We could assign these trees 2 meters and make it wider if you want. Let's keep it just like that for now for demonstration purposes. Okay, so we have our new canopy DSM. So if we generate again the pseudo color, okay. So then we have our green wall in front. And the last will be our land covers. And we need to include in the land covers the green roof. So how it works, a similar way that I showed you before. If this is your building and this is this is a building and you a portion of the building wants to be a green roof, so you will need to replace this information in the land cover as a grass, for example. So we have 7 classes in land covers. 1 is paved, 2 building, 3 is evergreen tree, 4 is deciduous tree, 5 is grass, 6 is bare soil, and 7 is water. Okay, so the next step is just to create this land cover. I want to create a land cover for the existing scenario, and then I will create a land cover, modify land cover for the new scenario. Okay, so I will export this before making any mistake. This will be our canopy DSM for scenario 2, and I will preserve the rest of the information. Okay, and we'll remove this. It's a bit tedious sometimes. We have to repeat the steps, but that's it. Okay, so we have our green wall here. We can visualize it to see how it looks. You see the green wall there. It's not precise, that's why it's just a visualization, but this assumes the sort of the height of the canopy. So that's why it's very important you put these points very close to each other, because we'll try to create a conical shape and put a correct height, etc. Okay, so now the next step is the land covers. So let's forget about this. Let's go to our initial buildings and DEM and DSM. So we already have here the buildings. Okay, so why to overcomplicate our life? We just can create as an export of this, and we will call it land cover, and we save it there, and then we call it land cover S01, simple, and we save, and that is the zone. All good, and we do you want to override? Okay, yes. No, it cannot override. It's because here there is existing land cover. Let's delete this land cover. Oh, and doesn't want to delete because we already have it here. Now we can delete it. No, it's not deleting. Software sometimes doesn't work. I will restart everything just to let me refresh. Sometimes happens like that. Let's see if now wants to delete. Is locked, so it doesn't delete. So we don't need to restart. We just do this. Delete. No, we need to restart it. QGIS. So here we are. We will open our project. Okay. Here we are. Let's go delete these because they already existed there. We cannot found for some reasons. We will do something different. Don't worry. We export, save as. That's okay. Instead of land cover, we will call it land cof. Scenario 1, simple. The zone is there. The geometry is a polygon, and we put okay. So that's created. So here we have our land cove. Let's change the colors because this doesn't help to visualize properly what we want. Okay. So that's our new land cover that we're going to start editing. Now, notice we don't need building heights. What we need is IDs. So we are going to create a new field called land LC type. Okay, land cover type. We use an integer, and the length is okay, 10 is okay. And we don't need the building height anymore. Then we just know that all what we have are buildings, so this will be number 2, correct? So we edit all of this. You can also, instead of doing manually, if you have too many buildings, you can do it with the field calculator if it is easier for you. Yeah, that's it. And we stop editing, and then we have all our buildings with number 2. Remember the numbers here, okay? So, okay, this is the land covers for the first scenario. We shouldn't have that building here, right? Because it's the first scenario. So what we do is just simply, we are gonna create another copy, sorry, and we are gonna export and save feature as, and this will be land cover scenario 2. We save, and we add it to the file. We put the geometry polygon and okay, and we add it to the file. So we have 2 land covers, the 1 and the 2. Let's start editing the number 1. I show you how to do this in a previous tutorial. So we just simply start editing the toggle, select the building, and we're going to delete it. So this is our first scenario, first land cover. Then we're going to start building some basic content information. What we'll need is just to digitize it from perhaps the satellite image. I already show how to do this, so I'm going to speed up this process. And remember that grass is number 5, so we don't need an ID. So again, we just open the attribute table, we delete, we don't need ID, we just need the type, that's all. And we start building. Otherwise, we will lose track of our ID numbers. The type is number 5, okay, which is grass. Then let's assume this is grass as well. It's number 5. Let's keep it simple, not to spend so much time on this. I will create a grass area. This is bare soil, so let's do it very simple. Let's imagine this is grass. Okay, number 5. And don't forget here to choose avoid overlap, and then what we'll do is try to do this. It's a trick. Go beyond, and this will be bare soil. Bare soil is 6, so let's imagine this is 6. And you will see that they don't overlap, okay? Which is perfect, what we want. And finally, turn on the DM. We are going to pave the rest, okay? Paved, to make it simple. So let's grab the last one and go beyond the size of your study area, and then paved is number 1. So this will be number 1. And again, double check that there are no overlappings. It's perfect, okay? We save this. So we have our first land cover. Now we can copy these elements and put edit, copy features. And what we grab is we go to our, we save, stop editing, and we go to our land cover 2. With this, we turn on, and again, the building is there, and we copy, we avoid overlapping, and then we put paste features, okay? So that's what we got. We got this now cropped around the building. So we have the building, the bare soil, the grass. Now we want to change some things here. So for the newest scenario, I will keep the bare soil here just for demonstration purposes, how the mean radiant temperature changes, but you could add more grass if you want. But I want part of this building to be a green roof. So we can do that by splitting or cut the feature. Splitting the feature in 2, or we just build a new building there. So this is land cover, remember. So I want to have this building partially green roof. So what we'll do is just simply delete it. We draw a new one in which part will be a building. And again, we don't need IDs here. So we delete the IDs. Okay. So we partially make this a building. And building is 2. And partially we make it green roof. Okay, so number, green roof will be a grass. Okay, so what happened here is because the DSM assumes that there is a height, this will be considered part of the building with a height, with wall and everything, but the land cover will be assigned to the roof of that building. Okay, and remember what I showed you before, when you have here, these are your second buildings. Building 2. Where it is. Let me change the color here because otherwise. Okay. So what I don't want to do is it's exactly this. The a canopy or shading device, I don't want to assign any building type. Okay, and I am doing this because simply, there is a mistake here. Sorry guys. Look, the buildings, they're not equally, so my mistake. So what we have to do is match them. So we copy this, we come here to this line cover, and we paste, and then we just change the vertex there. Okay, okay, okay. So I have to redo this guy, sorry. Good. So this is the line cover 2, correct? That it is the correct one. Now we save, and we will going to split now into the partially building, which is number 2, and partially green roof, which is number grass 5. Okay, and when we turn on this, you will see again there is an error. Yeah, where the area corresponding to this element here, the canopy, the shading device will not be selected. It will remain as a bare soil. Okay, so it's not assumed as a building. That's the whole thing. So now we deselect everything. Okay, so we have everything ready. We have our, we have for the land cover 1 and land cover 2. And then we do the same I showed you before, which is we're going to override or rasterize values. Here what we're going to do is grab the DM, and I will export it as, I will call it land cov scenario 1. Yes, and we'll, oh gosh, where I am here, generated UMEP, so data sets, and then I will call it land cover scenario 1. I will save it there. The rest remains, and we add it, and then this same one we export, save as land cover scenario 2. Correct? Okay. So now the next procedure, we save everything. We go to rasterize, override with attribute, and we choose first our land cover scenario 1. The input raster, the vector will be land cover scenario 1, correct? Land cov. And our land cover scenario 1, and the type not burning, okay, remember that, and we run it. And that's it, close. And now we're gonna do the same with land cover scenario 2, land cov scenario 2, that all good, type, we run it, and we close it. We have to re-add these values to the here. So this is a scenario 1, this is a scenario 2. Okay, let's check if everything is fine with the style. Scenario 2, it didn't copy the grasses, so I need to remove this and copy the grasses. So I need to copy these. These are grasses, and come here and edit the land covers too. Oh, there are the grasses there, but maybe the number is the wrong one. Yeah, they were copied as a, okay. So I want to send the selected ones, they were nulls. Because you have, I forgot to assign the values. So that is very critical. I made a mistake here. So this is the number 27, the number, yes. So they were not assumed as buildings, okay. As they were assumed as buildings. So simple, we go here and deselect everything. Let's go here and let's check our nodes, which is this one, which is a grass, number 5. This one, which is a grass, number 5. 5. This is paved, which is number 1. This is green roof, which is number 5, which is assumed grass. This is bare soil 6. This is building, which is number 2. And number 32, that I don't know where it is. That it shouldn't exist. So we delete that one. And that's it. And we save this. So that was my mistake. Let's redo the land cover number 2. That's why it's good to check. This is land cover number 2 is wrong. We are going to rasterize the land cover number 2 with this one that is already there. Type and run. Close. We remove the layer and we add it again. So now it's correct. That's land cover number 2. So let's check now. Land cover number 1. Now here the style. Correct. Land cover number 1, grasses, bare soil, paved, and buildings. Now let's cover number 2. Let's copy our style the same. And then you will see the difference, right? Now we have all the data that we need and we just run the UMEP. So I will go fast here because I already show we're going to run the SOLWEIG with all this information. So the first step is just we need to generate the spatial data, the sky view factors and in urban geometry and the wall height and wall aspect. So we start with this. It's building a DSM. So we start for the first scenario. Then we use vegetation canopy DSM from scenario 1. That's it. Our output folder, we can go to UMEP data sets and then we can put sky view factors, scenario 1. Simple like that. Select folder. And we can add the results and we run it. It will take a while. So here there is, it was generated. These little errors that appear here are obviously because of the spurious trees that are around, but that's the sky view factor. Okay, so that's the first thing done for the scenario 1. Now we will repeat the same for the scenario 2. DSM 2, canopy 2, tree trunk. We have these values. This will go to another layer, another folder. We will call this new folder sky view factor underscore scenario 2. Okay, select the folder and we run it with this new data. And we will wait a bit as well. So here are the results for the second one. As obvious differences, you see here the presence of the buildings, the new building and the new canopy is just there. So this is the second generation of the sky view factor. So for me, it took 10 minutes each model. I just paused the recording, but it will take quite a considerable amount of time for you as well. So having done that, now the next step is wall and aspect. So again, DSM scenario 1, calculate aspect, and then we select, and we will call it here wall aspect S01. We save, and then we call this wall height S01. See, aspect and height, double checking that everything is at the results, and we run. And this should run faster. Okay, here they are done. Okay, successfully. Then we have the aspect, and then we have the height. Good. And we will redo the same for the DSM2 aspect, scenario 2, select height, scenario 2. We add the result and run it. Much faster. Okay. Okay, that's done. So we have the aspect and height of the scenario 2. So we have all the data that we need. The other input data is the methodological data, and I already show how to generate this from EPW. Here I already modified the year. Let's imagine this scenario is for 2050, and I increase the temperatures. So all the data is ready. I only want to run it between 11 and 4 p.m., which is the peak hours. I don't want to make the model longer than this. It's easier and faster. So now we will run the first model, the first scenario. So we have DSM, Digital Surface Model 01. We need to choose the S1 Skyview factors. That's the zip folder. Vegetation, canopy DSM1. Then we use our land covers for scenario 1. Then we can save the generated building grid to mask those values you want, ground EM, aspect, and height. This is the basic setting. The methodological data is the one that I already have here. And don't forget your UTC. I made that mistake previously in the previous email. To find the correct UTC offset, this case is 11.4 Canberra. Then I want to save the output map, the mean radiant temperature, and I don't want to do anything else, and add the mean radiant temperature also to the project. I select a folder and I will call it output is scenario 1. Okay, so let's select the output is scenario 1 and run it. It will take a little bit as well. Okay, the model is successful. You can see here the model is there. Now this is the average. Now let's run the scenario 2. So we just change here the information, scenario 2, the canopy 2, the land cover 2, the DM is the same, wall aspect 2 and wall height 2. The same methodological information to compare the influence of the building and the trees and the green roofs and the green walls and the shading. And then we'll select a different output. We put new folder, output, scenario 2, save. We select that folder and then we just run it. Okay, model successful. So here we have the two mean radiant temperatures. Obvious differences here, right? But this is just the average. So we just can use a pseudo color. This one here, the spectral. We want to run it between. Here is very important to double check this. So 38 degrees and 75. That's what you want. I want 38 minimum to 75. And obviously we need to invert color, and that's how you see Okay, and then let's do the same with this one. 30A to 75 invert palette. So when you turn it on and off, you will see the differences. Obviously, the first one has errors because of the DSM. As I said before, there were plants here, so we need to double check that. But you see, I want to focus particularly in the scenario modeling. You will see here, this is the area we intervene, the climate sensitive design. So you will see the presence of the trees cools down considerably these streets. Okay, and also the presence of the building generates some new results around the building. Notice here the green wall. This is the effect of the green wall. So if we assess here, it's 69 degrees, and originally was, we can do this for both layers. So it is here 69 originally and reduced to 52. Then we have also shading here. Identify all the tree. Oh, I have one more selected, or let's remove this. This is what I want. Just give me 1 second. Yeah. So here we have one tree that before didn't exist. So the temperature has reduced from 63 degrees to 42 degrees. Here the temperature has reduced from 69 degrees to 52 degrees. Now, the roof of because this is a green roof, there is a significant difference. Here, the temperature 63 in the new scenario, and here 72. So it's a significant difference. Then, obviously, the shading device is also creating a difference around it, around the area. So you see here, the scenario modeling really helps to test different mitigation, heat mitigation strategies to improve outdoor thermal comfort. And that's why it was a bit tedious, the process, but you notice that we need to build all the elements in a logical way. So you need to design a workflow first, starting with the trees, adding the the building, sorry, and then locating green walls, locating green roofs, locating the trees. Then you start generating the different data sets inputs for the second scenario that's you needed, and then test different options, and you will see that the results of improvement in the outdoor thermal comfort makes a lot of sense. Okay, so this is all for the tutorial. Today was a bit longer than usual, but because there is a lot of processes for climate sensitive generation, and I hope you found this very useful to test different ideas and scenarios, improve outdoor thermal comfort, and run different simulations with this tool SOLWEIG, which is quite straightforward and fast. So see you in the next tutorial on UMEP. We will focus on the tree planter, which is a new tool available for SOLWEIG, also as part of the UMEP plugin. Okay, see you next time. Bye bye.